Kia ora, Year 11 and 12. This is the second video I'm doing on the difference of two squares. So go and watch the first easier one before you get into this, if necessary. So in this problem here, the first thing I notice is that I've got a common factor of 3. So let's take that out. But just before we go any further, I haven't looked at my y terms to see if there's a common factor there too. And there is. So I've got 3y times 1 minus 9y to the power of 4. So why does that make me feel much happier? Well, if I look back at this first one, 3 and y are not squares. Well, they are squares, but they're not easy, obvious squares. Neither is 27, nor y to the power of 5. But once I've taken out the common factor, 1 is a perfect square, so is 9, and so is y to the power of 4, because it's an even numbered power. So that means that I can factorise it in my usual way for the difference of two squares. So I'm going to have the square root of 1, which is just 1 plus 3y squared times 1 minus 3y squared. If you're feeling squeamish about that, we can just expand that out to check, which should end us up back where we started. Look, I've got 1 plus 3y squared minus 3y squared plus 9y to the power of 4. So that's with all our usual bits of the quadratic. Which one am I missing? That one there. Okay, so that's what all of these harder examples go a little bit like that. Okay, here are the next two. Have a go at these. Again, we're looking for common factors. So with this first one, the common factor in the numbers is 2, and there's no common factor with my variables because I have a squared and b to the 8th. So factorising the 2 first, we get 2 times a squared minus 9b to the power of 8, which fits a perfect difference of two squares pattern. The square root of a squared is a. I'm going to have plus here, minus here. Here I'm going to have 3. Now be careful with the next bit, it's going to be b to the power of 4. Remember that when I multiply exponents together, if they've got the same base, I just add the powers. So that's the second question done. The third question looks weird, but it also fits the difference of two squares pattern. This is a square minus another square. So we look at the square root of 3x plus 5 squared. It's just 3x plus 5. Here, my second term is going to be 2x plus 3. So it's going to be plus, I'm going to leave my brackets in to be careful, and here I've got minus 2x plus 3. So expanding this out, I get 5x plus 8 times 3x minus 2x gives me x, and I have plus 5 minus 3 giving me plus 2. So that's factorised now because it's written as this times this. If I wanted to, I could go on to expand that out. It would depend on the problem I was working with, or I could solve an equation if it came up there too. But when we say factorise, we just mean get to this form here. Okay, 2 left to do, and I've put some fractions ones in for the last 2. Right, let's look at our numbers first and see if we've got any common factors. No, we haven't. We've got 25 and 36, but they're both square numbers. So we look at this first one and we say, what is the square root of 25 over x squared? It'll be 5 divided by x. So we have 5 divided by x with a plus and a minus. Now turning to this one, what's the square root of that term? It's going to be 6 over y, 6 over y. So that's that one done. And our last one, very, very similar. First checking for common factors, 36, 49, nope. This one's very easy to check because its only factors are 1, 49 and 7. and 49 and 7 are not factors here, and there's nothing going on with 25. But we can see lots of square numbers everywhere. So the square root of the first one is going to be 6a over 7b squared. Right, I'm halving that power. I have a plus and a minus. Now looking at this last one, square root of 25 is 5. Now the square root of c to the power of 6 is c cubed, because if I do this, if I square c cubed, I will get c to the power of 6. So that's this one finished. Do all of the difference of two squares ones in the last part of 1506 if you want more practice, and remember I haven't yet gone through the perfect square pattern. Thank you for watching.